Hello again, this is Uncle Hippie, and let's get this out of the way right off the bat. I do have some forehead damage, and I will give you a couple of choices of what you think may have caused it. Number one is maybe I was on a lawnmower going under a low branch too fast, or possibility number two is my wife, my stove wood, and none of your business. So we will leave it at that, and you can just make up your own mind about it. So today we're going to talk about the relays some more, but more importantly, we're going to talk about one of the most important circuits that is possible to have for a relay. We're going to talk about the start-stop circuit. It is very common. It's used throughout industry. It's used time and time again. It's something that you really need to know. This is the diagram of it. We will go through it in detail, but I just thought I'd give you a sneak peek at it. Now, you can see that there's a relay used in it. It is called CR1. And that stands for Control Relay 1. And if you look at the drawing, you will see there is a coil at the end of the line called CR1, and there's also a contact right below the start button. It is also a coil called CR1. That is very important to remember in the relay world when reading a schematic. Any contact that has the matching nomenclature of the coil is related directly to that coil, and that contact will change states when and only when that relay is energized or has power applied to the coil. Now, for a quick review of the electromechanical relay, which is what we'll be using in this particular part. Relays, electromechanical relays, have a swing arm, and the proper name for the connection of that swing arm is common. We will get into common later, but in this particular case, common means where the power source comes from for that particular set of contacts. And there will be one normally open and one normally closed contact on each of these, because in this particular case, we're going to use a triple pole double throw relay. That means there are 3 poles, and each of them has a normally open and a normally closed contact. We will only use 2 of those in this particular case. We will use one for the sealing contact, which we will talk about. And we will also use another one to turn on and off red and green lights, red indicating the circuit is off, green indicating the circuit is on. And we will talk about that. Now, you will see there are a couple of brand new symbols that you may not have seen before on this drawing. One of them is a normally open push button, the other is a normally closed push button. They are mechanically operated by depressing the button. Just these are the symbols. And as you can see, the normally open push button is open and does not allow current to pass. The normally closed push button is closed, and it does allow current to pass. Another component that's going to be new this time is the light. It can be any kind of a light. This is the symbol for it. The only difference between this symbol and the one you will see is in the center, the green stands for a green light, and the R stands for a red light. And if it's yellow, it would be Y. If it's white, it would be W. If it was blue, it would be B. So it just indicates the color of the light in the center of the circle. Something else that will be new in this lesson, we will start the very basic schematics. We're going to start with something called a ladder diagram. And the reason it's called a ladder diagram is because it looks very much like a ladder. The horizontal lines are called rungs. The vertical lines are called rails, just like in a ladder. As a normal situation, the power side, or the power is delivered from the left side and goes to the common, which will be on the right side. Okay, let's talk about how a start-stop circuit works. It's really important to know this because it's one of the most commonly used circuits, and as far as I know, it is the most commonly used circuit anywhere. If you look at the drawing, it looks like this. We start out with a plus source. It can be any voltage, but in this particular case, we're going to say 24 volts DC, because that's what we're going to use for our experiment today, and we want to keep it safe, and 24 volts DC is safe. Okay, it leaves and it goes through the stop button, then it goes through a start button, and there is a CR1 contact in parallel with the start button. Now, if you'll remember, we talked about series and parallel circuits. The stop button, the start button, and CR1 are all in series, and the CR1 contact is in parallel with the start button only. Okay, let's take a look at a schematic that we're going to determine what happens with the current while this is happening. Remember, the red denotes there is a power source present, and black denotes there is not a power source present. So let's take a look. Okay, when you start off, the both buttons in their normal state, which means the stop button is closed and allows power to pass through. The current can get through the stop button. So with power applied to the 24 volt DC terminal, power flows through the stop button, it goes to the start button, and it goes down to the power side of the CR1 contact. And at this point, nothing is turned on. So let's take a look at what happens when we push the start button. Okay, if we push that start button, it allows power to flow through that start button, and it allows power to get to CR1, which is the coil for the relay. When that power reaches that, it energizes that coil, the magnet turns on and pulls in the contact, which is called the sealing contact in this particular case. Now with the push button released, if you take a look, what happens is the circuit stays on. When the sealing contact is closed, the start button is released, the relay CR1 will stay energized until the stop button is depressed. So that's why it's called a sealing or latching contact, because it latches the circuit in. You no longer have to have the push button pushed in, the start button pushed in order for the circuit to stay on. It's really important in the electrical world to be able to do this, and it's pretty much impossible to do hardwired without a relay. Matter of fact, it is impossible to do without a relay. So anyway, now let's take a look at what happens when we push the stop button. Alright, we've pushed the stop button now, and when the stop button is pushed or depressed, current flow to CR1 is disrupted, and the relay is de-energized, and the sealing contacts on CR1 then goes back to its normally open position. So now that we've pushed the stop button, the circuit is now de-energized. Okay, the stop button has been pressed, the circuit's de-energized, and now the stop button has been released and it goes back to its closed position. The power then all goes back to its original state before we push the start button. So now we have a means to push a button and maintain a circuit, and push another button and stop that circuit. Let's take a look at the circuit that we're going to design and build today. I've done this a little bit differently just for the sake of simplicity. Each wire group has its own color. That way it's easy to follow when we do it. Normally these wires would be numbered, but for this particular case, I just thought it might be a little easier for you to follow if every wire was a different color. So let's take a look at that circuit now.
Alright, let's take a look at a push button. Okay, this particular one, it's red. It's a red push button. It has an extended head. And the orangey colored back denotes, in this particular case, that it is a normally closed, which means when it is not depressed, it will conduct. Very simple. You push the button, it opens the contact. You can see in the back, possibly you can see that. Okay, this is a black. It's covered on the end, and it is a green, which denotes normally open. So what happens when you push the button? It closes the contact. And again, you can probably see on the back, see that moving in and out. So it's a mechanical device that opens and closes the contacts. They are spring loaded, and they are called momentary because they are only changed in state while you have pressure on the push button. Okay, when you press the button, it changes the state of the contact. This one is normally closed. When you push the button, it opens it. This one is normally open, and when you press the button, it closes it. Okay, did you get that? Well, I tell you what, let's do it a little bit slower. Maybe we can figure out exactly what's going on here. Okay, we're going to start with a blue wire, and we're going to take that to the plus on the 24 volts. It goes from the plus to the stop button. Here's our stop button. And it also goes to one of the swing arms on relay. And we're going to take this to the second one. So we're going to use this one. We're going to use the middle one for that. This is a 3-pole, double throw relay. Okay. Now, that takes care of the blue wires. First of all, it goes to the stop button. Then it goes to one side of a set of contacts. It goes to the swing arm part. Okay, now, this one goes from the stop button, it's a red wire. Okay, it goes from the stop button to the start button. And it also goes to one side of the sealing contact, going from the stop button to the start button. And we're also going to go to one side of the sealing contact. Now, we're going to go from the other side of the start button, and we're going to use a black wire for that. We're going to go to the normally open contact, which is the bottom one, for the sealing contact. And we're also going to go to the coil of the relay. I'm going to take a blue wire with a black stripe, and we're going to go from the negative on the power supply to 14, which is the common for the coil. Now, that also goes to the common on both lights. And we're going to go from the negative to the green light.